I'm Lee C. Camp, and this is No Small Endeavor, exploring what it means to live a good life.
Technology being advanced is enabling us to make rapid discoveries about the universe, about nature, and that is informative to us, but it also informs other things that we care about as human beings.
That's Jennifer Wiseman, Ivy League-trained astrophysicist, author, and speaker, and she spent a great deal of time facilitating conversation between religion and science.
Science should be seen as actually a gift to wonder and awe, and not something that's taking wonder and awe away.
Dr. Wiseman joined us in Nashville at the Sudekum Planetarium in front of a live audience where we discussed her work studying the formation of stars and planets, as well as the ways in which her faith relates to her work as a world-class scientist and the implications this has for how we understand the meaning of our lives. Coming right up. Hello all, it's that time again for our annual Thanksgiving show on Sunday, November 19. This year it's at the beautiful Schermerhorn Symphony Center in Nashville, and have we got a lineup that you do not want to miss. Author and podcaster extraordinaire Malcolm Gladwell will be joining us on stage, as well as legendary country music singer our friend Vince Gill, and celebrated bluegrass guitarist and aficionado Brian Sutton, and players from the Nashville Symphony. It will be our usual fare of combining art and conversation to explore what it means to live a good life. Don't live in Nashville? 2 suggestions. Come on in to Music City, make a weekend of it. Or if that doesn't work, buy a live stream ticket. It's the highlight of our year. Buy your tickets now by going to nosmallendeavor.com. No Small Endeavor thanks our sponsor Lipscomb University, located in Nashville, Tennessee. Students at Lipscomb University are part of a Christ-centered community that prepares them for lives of purpose through rigorous academics and transformative experiences, where academic inquiry, grounded in a rich tradition of faith, shapes people of character who will impact the world. You can learn more about Lipscomb or schedule a visit at lipscomb.edu. I'm Lee C. Camp. This is No Small Endeavor, exploring what it means to live a good life. Since I was a boy, I've loved reading about those out on the edge of the frontiers of discovery. The Wright brothers at Kitty Hawk, Charles Lindbergh making the first transatlantic flight in the Spirit of St. Louis, Chuck Yeager breaking the sound barrier in the X-1, or reading about the early NASA programs, first Project Mercury, and then the Apollo program taking humankind to the moon. Since then, as a layman in the sciences, I've read my way into astronomy and cosmology and find myself awestruck by the wonder of it all, and thus wondering, what does a human life even mean in light of such awesome, spectacular immensity? Then recently we invited Dr. Jennifer Wiseman to Nashville, a world-class astrophysicist, science policy expert, and lead in a great deal of religion and science dialogue. We gathered with her beneath the beautiful dome of the Sudekum Planetarium in Nashville, and I was rather giddy with it all, and believe it or not, so was she, with spectacular scenes from the Hubble Telescope, a project Dr. Wiseman happens to direct for NASA, and spectacular scenes from the Webb Telescope, projected above us there in all their glory. And in that context, a conversation with provocative and critical commentary about it all. Here's our conversation, and a reminder that along with this version, you can also get the unabridged version on our podcast. Dr. Jennifer Wiseman is an astronomer, author, and speaker. She studies the process of star and planet formation, has worked with several major national observatories. She's also interested in national science policy and public science engagement, is Director Emeritus of the Program of Dialogue on Science, Ethics, and Religion for the American Association for the Advancement of Science, received her B.S. in physics from MIT, her Ph.D. in astronomy from Harvard. She's continued her research as a Jansky Fellow at the National Radio Astronomy Observatory and as a Hubble Fellow at the Johns Hopkins University, then served as a Congressional Science Fellow of the American Physical Society and is now a Senior Astrophysicist with NASA. Dr. Wiseman is a Fellow of the American Scientific Affiliation, grew up in Arkansas, and now here she is in Nashville, Tennessee. One more time, please welcome Dr. Jennifer Wiseman. Well, welcome. We're glad that you're here in Nashville.
Thank you. My pleasure.
Yeah.
Yeah.
So I was geeking out backstage, just getting to talk to an astrophysicist. Why don't you begin by just telling us a little bit about what an astrophysicist does, and some of the things that your discipline entails?
Sure. Well, astrophysics is just what it sounds like. So it's using physics, which is basic science, to understand the forces of nature, to understand space, astronomy. So applying physics to observations taken with telescopes and trying to understand what it's telling us about the universe and how it works. So that's why I sort of went into astrophysics, because I just thought the word was cool, but now I think the actual science is cool too.
And so what are some of the tools that you're developing? I mean, you're obviously working with one of the most internationally well-known tools for astrophysics, but tell us a little bit about that.
So we now use in professional astronomy many different types of telescopes. So there are telescopes in space, there are telescopes on the ground. The most famous ones you've probably heard about are, of course, the Hubble Space Telescope, which is in great shape and is orbiting the Earth right this minute and doing wonderful science. There's the new Webb Space Telescope, which is complementary to Hubble. They see different kinds of light, so we're so excited to have both of these facilities. There's a Chandra X-ray Observatory. There's quite a few other telescopes that either are or have been in space. We use facilities on the ground as well. The Keck telescopes in Hawaii, the ALMA submillimeter and millimeter wavelength radio array in South America. I use the very large array in New Mexico for my own research in star formation. There's lots of others on the ground. We're also using some different kinds of observatories now to gather even different kinds of information. There's a fancy term now that we call multi-messenger astronomy, and it means that we're getting information not only from radiation, like light and different kinds of light, but also from particles that are emitted from some types of phenomena in deep space that eject, let's say, charged energetic particles that travel across space, like the solar wind, these kinds of things, but also from more energetic events in deep space. We have detectors for that. And for gravity waves. So gravitational waves are disturbances in space-time itself. And, Einstein, of course, predicted this might be the case, but we only in recent years have started to actually pick up those disturbances using detectors on the ground. And they happen when there are often massive bodies in deep space that are accelerating or like merging black holes or merging neutron stars. And that can create such a significant disruption in space-time that we can actually detect it as that disturbance travels our way. So there are different tools that we use in astronomy and astrophysics to measure and to detect phenomena in deep space and to try to understand what it all means.
When you think about the things that you all have been learning, I guess major developments in the last 30 years or so that we weren't able to know previous to that time, what are some of the major findings, developments that have occurred in the last 3 decades that we could understand in layman's terms?
What a fun question. Okay, so how many hours do we have? Oh, okay. We are learning so much. And here's an example, I think, of how technology being advanced is enabling us to make rapid discoveries about the universe, about nature, and that is informative to us, but it also informs other things that we care about as human beings, philosophy, theology, art, all kinds of music, all kinds of endeavors. So some of those discoveries, if I have to pick out a few from recent years or decades, I would think, for one, we have discovered that the universe, we already knew it was enormous, but we know now that it is not only enormous, but it's very rich. There are hundreds of billions of galaxies just in the observable universe that we are able to see, that there's been, sufficient time for the light to get to us to see. those galaxies, and each galaxy can contain billions or even hundreds of billions of stars. So if you do the math, it's kind of mind-boggling. And we can start to piece together even the history of the universe by comparing the more distant galaxies, which means we're looking farther back in time, with the ones closer to our own Milky Way. And we can see that galaxies have changed over time. They've merged with other galaxies. In fact, we've seen quite a few galaxies in the act of merging with other galaxies, and that makes them bigger. But also, when they have time, stars come and go. As I showed you in that butterfly nebula, stars begin to release what they've produced in their own fusion process in the core, and that enriches the surrounding circumstellar and interstellar gas, and then next generations of stars pick up on that and have heavier elements at their disposal. So now when we look at stars forming, they have dusty bands around them and planets forming in them. So one of the things that we've learned is that the universe is not stagnant. About a century ago, there was a big debate about whether the universe had always been here in a steady state, or whether there was a beginning, at least to the universe we're experiencing, and whether things have changed over time. And now, there's agreement that the latter is the case. And of course, we have evidence also from the cosmic microwave background radiation that our universe had a beginning. And we can see that the leftover radiation from that very energetic start. So that would be one thing. And so there's a lot of studies now on what's making up the matter in the universe. Most of it is actually unseen, but it's dark matter. We can see its gravitational effects. So we're looking at how dark matter interacts with other matter within these galaxies and between them. We now know that the universe expansion is accelerating. That was just discovered not too many years ago using Hubble and some telescopes on the ground. And that was a big surprise. When I was in graduate school, we thought that the universe was expanding, but that expansion must be slowing down because gravity would be trying to pull things back together, right? And instead, through more careful measurements of galaxies like the ones you see here, both distant ones and nearby, and their apparent radial motion as they're actually caught up in the stretching of space, you can tell that in the past, while the expansion was slowing down, nowadays that expansion is actually speeding up. So that acceleration is a big surprise, and we just call the force behind that dark energy. Hot topic in astrophysics right now. What is dark energy? How has it worked and interacted with classical attractive gravity over the course of the history of the universe? And then one more I'll throw out to you is that closer to home, like in our own Milky Way galaxy, we have started to detect lots and lots and lots of planets around stars other than our sun. So again, when I was back in graduate school, we didn't know any planets around other stars other than the planets in our own solar system. But the technology started getting better and the techniques began to be developed. And so one by one, and then hundreds by hundreds, and now by the thousands, these exoplanets, which means planets outside our solar system, have been detected. And now it's one of the hottest topics in astronomy is trying to not only detect exoplanets, but characterize them. It's a really exciting time in astronomy and astrophysics.
When you think about 13.8 billion years, or the unimaginable largeness even of our solar system, or then our galaxy, or then the universe, do you have any favorite metaphors or illustrations that can kind of help us begin at least to get at the magnificence or the awesomeness that we're talking about here?
What is, I think, sometimes mind-blowing is even just thinking about our own solar system, right? If you have ever done one of these planet walks, and some science museums have these where they do a scale model of the solar system where the sun is in the middle, and then a few steps out would be Mercury, and then Venus, and then Earth, and you keep stepping out to Mars, but by the time you get out to Uranus and to Jupiter, Uranus, Neptune, and so forth, Saturn, you're football fields away, by the time you get to the outer solar system where dwarf planets like Pluto and its companions are. And that gives you, I think, a sense of our own solar system. And then if you think about it, that the The nearest star system to our sun in our galaxy is the Alpha Centauri system. That's 4 light years away. So even the closest star, we're looking at it as it was 4 years ago. It's taken light 4 years to get to us. So we use light years rather than miles or kilometers because the numbers just get very, very difficult to handle. Our own galaxy is something like 150,000 light years across. The next big spiral galaxy to us is Andromeda. It's a couple of million light years away. So the distance scale quickly becomes unimaginable. And then, like I say, the content of galaxies is unimaginable too, because we can spew out the numbers, hundreds of billions of stars and their planets in one galaxy, and then hundreds of billions of galaxies, but we can't really contemplate what that is.
You're listening to No Small Endeavor and our conversation with astrophysicist Jennifer Wiseman. I love hearing from you. Tell us what you're reading, who you're paying attention to, or send us feedback about today's episode. You can reach me at lee@nosmallendeavor.com. You can also connect with me on social media at Lee C. Camp. You can get show notes for this episode in your podcast app or wherever you listen. These notes include links to resources mentioned in this episode, as well as a PDF of my complete interview notes, as well as a full transcript. We also have links to many spectacular images from the Webb Telescope on the show notes for this particular episode. We'd be delighted if you tell your friends about No Small Endeavor and invite them to join us on the podcast. Your sharing helps extend the reach of the beauty, truth, and goodness we're seeking to sow in the world. Coming up, Jennifer continues to discuss the things we are learning from studying astrophysics, how she inadvertently discovered a comet on a college field trip, as well as her conviction that science and faith need not be pitted one against the other.
Sometimes what you need is an ER right around the corner. Reassurance that it's heartburn, not a heart attack. Or a specialist who takes time to listen. When people come together, something powerful happens. TriStar Health's comprehensive network of over 1,000 clinical experts connects you with the right care, because sometimes what you need is someone to take care of you. TriStar Health, a network of care focused on you. Connect with the care you need at tristarhealth.com.
I'm Dr. Laurie Santos, host of the Happiness Lab podcast. It's never too late or too early to learn how to feel happier. So my new season has well-being tips for you, whether you're aged 3 or 103.
Or 6 like me.
Did I mention I have some amazing co-hosts for this season?
And do not forget cute and furry.
How could I, Grover? I'll be joined by my fabulous friends from Sesame Street.
That's us.
Hello, everybody!
Hey, fairy friends!
Be sure to listen wherever you get your podcasts.
Oh, I am so excited!
This is gonna be so magical.
So in the history of theology, philosophy, the word disenchantment gets used a lot of times to refer to, since the rise of the Enlightenment, the scientists, in effect, explaining a lot of observable things through cause and effect, through scientific method. And by disenchantment is meant that the sort of magical / spiritual / transcendent realities that we've assumed are at play in the universe get explained away. God of the gaps, for example, is this notion that previously, if there was something that people couldn't understand, they would just say, well, God explains that. And then the scientists would discover, oh, well, we can actually explain that through X, Y, and Z. And so the God of the gaps gets increasingly smaller and smaller of what you would point to God as explaining is in the universe. And so disenchantment is pointing to this kind of process in which ultimately it seems everything has been disenchanted because of the work that the scientists have done. But I've listened to a number of your interviews, and it seems to me that you often point to a notion of awe and a notion of wonder that doesn't seem to have been removed from your sort of psyche that you bring to your work. So how would you respond to that notion of the scientist as the one that disenchants when you seem to hold on to a sense of wonder and awe before all that you are seeing?
Good question, and that's a philosophical question. I would say in some sense, yes, if we thought that things in the universe that we can observe are somehow magical. And then with what I would call the gift of science, we can actually start to understand why things happen, little w, and cause and effect based on physical laws and principles. Then in a sense, that's a disenchantment. But on the other hand, there's this incredible realization that, wow, the universe that we thought just a few decades ago was pretty stagnant, we now see that it's incredibly active. We can see that it's changed over time. We can see that physical laws that we can sort of understand can help us understand why things happen the way they are. Why do we have this gift of knowledge? Why do we live in a universe where life can exist, at least on one planet? Why do we have the gift of comprehension to know just a little bit of the universe around us and where we fit in? And that's where I think that science should be seen as actually a gift to wonder and awe, and not something that's taking wonder and awe away. For people of faith, the question is not, what don't we understand, what doesn't seem to work by natural law, so that we, as you called it, God of the gaps, pull in God to sort of say, well, that's the magic wand. Instead, I think the right approach, at least for me, is that you feel a sense of amazement of what we're observing, what we're learning, a sense of gratefulness for the fact that we can understand more and more. And let that understanding deepen one's sense of faith, if you're a person of faith. I think of the Psalm 19 that says, the heavens declare the glory of God, and the skies proclaim the work of his hands. Day after day they pour forth speech. Night after night they display knowledge, and yet they're not using words. And yet somehow their message is observed throughout the world. Now, that's a poetic psalm, and yet I think it's the right response, right? We can look up and have a sense of amazement, even as, and perhaps because of, the fact that we can analyze and understand the physical processes that are going on. So I would say that scientific understanding of natural processes can be seen as a way to, in fact, enrich one's sense of wonder and awe. And if you're a person of faith, it can actually enrich and deepen your appreciation of the God behind it all.
I mean, that relates as well to the question, I suppose, of purpose or significance. When we look at the magnificence of the universe, 13.8 billion years, in what ways has that challenged for you a sense of some sort of faith, of saying, really, can there be any sort of significance to humankind or human existence? Or, clearly we are a tiny speck. At best, right? At best, we're a speck. And so how have you thought or processed that notion of purpose or significance in light of such magnificence?
It's true, right? So it hasn't been that long that we've really understood the vastness of the universe, and that we truly are insignificant in terms of where we are. We're on a tiny little planet around one star that's in the outskirts of one galaxy that has hundreds of billions of other stars. And now we know, this is an amazing fact I'm about to tell you, we now know that on average, every star has at least one planet. We know that from the statistics of all these exoplanet discoveries we've been making in recent years. So planets are really common, and now we're trying to understand what they're like. And of course, there are all these other galaxies, and they may be full of planets too. And we now know that, as we've learned from Galileo's time, that the sun is not the center of, or the Earth is not the center of our solar system. The sun is, but our solar system is not at the center of the galaxy, and our galaxy is not in the center of the universe. And in fact, there doesn't seem to be a center of the universe at all. So what does it mean? And also in terms of time, we don't live very long, right? And life hasn't been around all that long, cosmically speaking. So what does it mean in terms of significance? If you measure this now, you jump from a scientific question to a philosophical question. How do we gauge significance? So if we gauge significance by place and time span, then we're not significant. But that's not new, because even if you look back in ancient literature, including biblical writings, they already realized that our lives come and go, that we're insignificant. The Bible, says so much as that we're like the grass of the field that's here today and gone tomorrow. So if you gauge your significance that way, you're going to be pretty disappointed and feel purposeless if you look out at the universe and think of yourself in it. But I think there's a different way of thinking of significance, and that is thinking about not where we are or how long we have, but rather think about the fact that we exist at all, and that we have the chance to live, to learn, to observe, to have some recognition of where we are in the universe and in this marvelous space, and to be given this gift. If you look at Psalm 8, for example, the psalmist says, when I look at the moon and the stars, and the psalmist didn't even know about galaxies at that point, the psalmist writes, what are we that you're mindful of us? He's talking to God. He's writing this psalm. He says, "Oh Lord, our Lord, how majestic is your name in all the earth. When I look at the stars and the moon, everything you've created, what are we that you're mindful of us?" And that's that appropriate sense of insignificance. But then the psalmist goes on and says, and yet, you've given us all this knowledge, this dominion. You made us just a little lower than yourself, and you've given us dominion over all things. Now, the psalmist knew that we couldn't reach up and manipulate the stars or even the moon at that time. But I think I would interpret that as including that gift of knowledge, that gift of understanding, that gift of observation. And that, to me, is where our significance might be coming from, that gives us a little bit of a more positive view of it. In particular, we have the significance of being able to make some choices about the things that we do have hands-on dominion on this planet, and how we use that knowledge. So for a person of faith, there's this significance that comes, you recognize it comes from the love of God, that the God that's responsible for the universe has also demonstrated love for those of us who are, quote unquote, insignificant in space and time, and yet God feels that we are significant in these ways by giving us the gift of life and the gift of knowledge, the gift of, in some sense, dominion, of understanding, and hopefully stewardship of what we have been given, and that gift of a relationship with God. So those are where I would say significance can be found.
I want to go back to childhood. You grew up in Arkansas?
I did.
Yes. How did you find your way to such curiosity and giving yourself to this line of work?
I love nature. And so growing up in the Ozarks of northern Arkansas, we're surrounded by nature, mountains, which are really hills, and forests and valleys and lakes and rivers. And I grew up on a farm where every day was different as you went through the seasons of the year. We have lots of wildlife. I care about all kinds of animals, whether they're livestock or wildlife or pets, and just observing all of that variety. I grew up with a deep love of nature, and that included seeing the night sky. So out on this farm, you could actually walk out at night and see a lot of stars. And I was curious about what I saw, and I wanted to know what it would be like if I could go up and, visit that star or that one. And about the time I was growing up, there was a lot of fervor about space exploration. Back in my junior high years in the 1970s, the Voyager spacecraft were first going nearby the outer solar system planets and sending back close-up pictures of those outer solar system planets and their moons. And I just thought this was fascinating. All these exotic moons like Europa and Ganymede and Io in our outer solar system. I wanted to be a part of that enterprise. And then the movies were coming out, Star Wars and all of that for the first time. So everybody was thinking about space in different ways. But I was fortunate that even though I didn't know any professional scientists or engineers at that time, at least working on space stuff, we had some really great teachers in our public school system. And my teachers really wanted us to have the confidence and a healthy sense of confidence that we could do whatever it is that we felt interested in doing and pursuing, and they supported us. And so I'm grateful for our counselors and teachers. I'm grateful for my family that opened up doors for me, and I'm grateful for the church family that I grew up in that were very encouraging for us to go and whatever we did, to do it as an act of service and to do it well and to reach beyond. So I decided to try to do something space-related and applied for colleges and places where I could study space-related sciences. And I'm so grateful that I was able to go to a university and study physics, which I felt was a basic science you could apply to many different choices of career path, but also kind of get involved early on in space-related research. And so I really appreciate colleges and universities that help their students get involved in internships and things like that, where you can actually see, not just from a textbook, but from hands-on interactive experience, how science and engineering are really done, and get that kind of experience. It's priceless, and I'm grateful that I got to have those experiences.
We're going to take a short break, but coming right up, how Dr. Wiseman inadvertently discovered a comet on a college field trip, as well as commentary on the way science and religion may complement one another. Hey friend, if you didn't know, I started a newsletter a while back that comes out every 2 weeks. I've been delighted to hear from so many of you about positive response to the newsletter. We call it the No Small Endeavor Notebook, where I riff on themes and topics related to our podcast, giving you additional material for thinking and doing in your own quest to make sense of what it might mean to live a good life. Join us by going now to nosmallendeavor.com and sign up there. Again, go to nosmallendeavor.com to sign up now for our free No Small Endeavor Notebook newsletter. Now, I understand that you went to MIT as an undergrad.
Yes.
And that, if I understand the story correctly, you go on a field trip as, a freshman in college to an observatory, and she's...
Senior.
A senior. So I'll tell the story as I remember it, and then you can correct the story. But the story that I recollect is that you go on a field trip as a senior in college to an observatory, and you're looking at some of the images, and you discover a comet that had not yet been discovered on your field trip?
Yes. So, but this is an example. Again, I told you about how much I value the internships. Well, you don't have internships or experiences like that unless you have people who are willing to sacrifice their time to enable those opportunities for students. So there was a professor there who every year took a group of students out in January to Lowell Observatory in Arizona. The late professor was Professor Jim Elliott, and he would take students out every year who wanted to learn what real astronomers actually do. And so we got to go to Lowell Observatory, and we were kind of paired up with working astronomers there, and to learn what they actually do and kind of shadow them for a few days. So I was paired with Dr. Ted Bowl, who taught me how to analyze these photographic plates. At that time, we were still using glass plates to take images through telescopes on the ground. and scanned them using something called a blink comparator, which allowed you to jump between one picture to another of the same region of the sky, but taken a few hours apart. So you're looking through this machine that's blinking between the two. And the stars in the background don't move in such a short amount of time, but anything in the nearby solar system will kind of jump relative to the background stars in the picture between those two images. And I was supposed to find a whole field of asteroids, and I didn't find a single asteroid, so I was failing my task on my first day there. But I found this other thing that jumped and seemed to have a long tail-like structure on the photographic plate after a while, and I brought it to the attention of Dr. Bowl, and sure enough, we measured the position of this thing, and there was no known comet or asteroid in that position. The long tail was simply a streak because the thing had moved so fast during the exposure. And so we went back with the telescope, and it had been several days, so I had to kind of guess where this thing might have moved in the intervening days, but took another picture of the sky and found it again. And the astronomer who was actually taking the picture through the professional telescope there is Brian Skiff, who is still an active astronomer at Lowell Observatory. So we sent all this information into an outfit in Cambridge, Massachusetts called the Minor Planet Center that's keeping track of all the known asteroids and comets in our solar system. I bet you guys didn't know about the Minor Planet Center. But they said, indeed, there was no known comet or asteroid in that particular position. And they sent out a telegram around the world, and some other astronomers, including some from Japan, confirmed this object. So I didn't have anything to do with naming it, but they have a procedure. So they named it Comet Wiseman Skiff after myself and Brian Skiff, who had taken the pictures through the telescope. And so that was very exciting because I was an undergraduate, and I didn't know whether comets are discovered, once a day or once every 100 years or what. It turns out that comets are discovered about a dozen a year kind of thing. But most of them, or many of them, are on like a one trip through the inner solar system kind of orbit. But this one is what we call a short period comet. So its orbit is closer in. It comes back close to the sun every 6.5 years. So that's really great, to have a short period comet. But it's also really faint. So you'll never hear about Comet Wiseman Skiff unless you really try. So you can Google it.
Are you tempted to queue up the Hubble Space Telescope to watch the Wiseman Skiff comet skim through the...
Well, absolutely. But what I really try to do, since my expertise is more in the study of deep space star-forming regions, and I really don't have the expertise of comet study, I try to get colleagues who are experts in comet studies to look at it every 6.5 years, because the orbit parameters kind of change a little bit every time. Comets can easily get jostled around a little bit by the gravitational pull of planets and things. So you want to make sure you see it regularly so you can keep a good grip on its orbital path and parameters. But here's kind of some interesting corollaries to the story here. First of all, I call this you talked about the interface of faith and science. So I was a senior undergraduate in January of my senior year, and to graduate, we needed a senior thesis. And I didn't even have a topic yet, much less a research thesis done to graduate. So I was praying for help, and then this happened, and then I studied this comet for some months and wrote up a research report, and that became my senior thesis. So it's my answer to prayer comet. I will say that
having a hard time as a professor myself, having a hard time imagining my student turning in a paper saying, "Oh well, I discovered a comet," and here you go. Yeah.
Well, I will say that most of my prayers are not answered so stellarly, but it does remind me. I take it as a mark of God's providence, because here we are decades later, and I get asked much more about that comet than I get asked about the subsequent research that I intentionally did for years and years on star formation. And it's not that it's all important, but I just find it interesting that I was in the right place at the right time to make that discovery as a gift. Reminds me of this gift of grace, and also the gift of all the people that enabled me to be there. The professor, the staff of the observatory, the teachers, all the people I just mentioned that enabled me to have this experience fed into that and makes me grateful for that grace. And then here's where I think, maybe God has a sense of humor, because there were some years later where there was an observation from a rover on Mars. Now, you're going to think that I'm just making the hugest non sequitur ever, right? But there's rovers on Mars. We've had quite a few over the years, but this particular rover, I can't remember which one, was taking regular pictures of the Martian sky. And it turns out that Mars has meteors just like Earth does, little pieces of debris that hit the Martian atmosphere and burn up. So just like we see what we call shooting stars, but this burning debris that comes into our atmosphere on the Earth, we call them meteors. In fact, there's a meteor shower going on this month here, but this rover caught a picture of a meteor in the Martian sky, and some researchers studied that in France and studied its trajectory and wrote a paper that said they believed that was debris from the tail of Comet Wiseman's skiff. You never know what happens when you enable people to be in these places where discoveries can happen. That wasn't planned, right? But it happened, and it helped propel me forward into graduate school to study astronomy and to have the chance at the career that I have. And so the more we can do as a society and as a world to open up doors for people to have these experiences, to be welcomed in. We're trying right now in our science institutions to look around and say, who's not here? There are demographics of people that are not equally represented in science and don't have the equal opportunities to come and have these experiences. What can we do to make science more welcoming to more people from different backgrounds and different demographics? It strengthens science. It strengthens our world. It gives young people something positive to aspire to. So I think that's something we can all take a look at.
So you've raised here then the question of community, common good with regard to science. So let me ask you a few questions about that. First one, you've alluded to the fact that you're a person of faith. How do you process the sort of resurgence, maybe is the right word, of antagonism between at least some elements of the Christian community in the United States and science?
I work in a field where humility is of the order, so I don't see or experience a lot of that antagonism in my particular realm of work or professional institutions, so I'm grateful for that. I think perhaps there are cases where people feel, if they've heard some public voices saying that what we're learning in science negates, the legitimacy of religious faith or something like that, that can be very off-putting, but it's also very inappropriate, because what science properly used, it's very appropriate for public spokespeople to say things like that, because science properly used is just helping us understand how physical processes of nature work. Science is not a tool to answer the big questions of capital W, why? Why is there a universe? Why is there something and not nothing? Or even the questions of, how should we live? These are things you can't answer with a microscope or a telescope, right? So science properly used is helping us understand the mechanisms of biology and astronomy and geography and so forth. It's improperly used when it's used to assert, philosophical pronouncements and things of that nature. So I think we need to be discerning about which kind of tool answers which kinds of questions, right? If we want to know something about how the universe has developed. We use scientific tools to discover that type of information. If we want to understand why there's a universe at all, not the physical reasons, but why, capital W, the philosophical, theological reasons, or, how do we have a relationship with God? What is the nature of God? Is there a God? Science is not the right tool. We have other tools, if you will, tools like the gifts of our sacred scriptures, or people's experiences, or philosophy, prayer, things of that nature. So I don't think there needs to be any antipathy. In fact, the idea of there being an antipathy between science and religious faith is a rather new phenomenon in human history, and it kind of developed, as I understand it, over the last century or two, particularly in the U.S. But the original scientists of the modern age, many of them were motivated to do their science because of their faith, right? Think of like Kepler, even Galileo, who had his run-ins with the Catholic Church, as we all know. But he was not an atheist. He was also a person of faith. He just wasn't very savvy politically, that's for sure. But many of the scientists on whom modern science based their work were motivated to do their scientific investigation as an act of worship. They were trying to understand God's handiwork. And that is the way many of my colleagues who are scientists of faith view their work today. And yet there still is this kind of sense that you might have to choose one or the other, and that's just not the case.
You've already spoken of humility a couple of times, but would you point to any other ways you're conscious of the ways a vocation as a scientist has formed you so far as your dispositions and the way you go about living life?
Well, I try to keep an eye open toward beauty and wonder. So I think that's what all of us here and all of us listening to this can make a pledge to every day, just look at a flower or look at something that's beautiful in the creation around us and be thankful and admire what it is. And right now we're in this planetarium looking at views of this majestic star cluster and nebula, and we should take time to be appreciative of being able to be part of that. So I try to keep a sense of gratefulness. And then science is actually a human enterprise, just like everything else humans do. So, we can look back through history and see how science has been done in ways that have actually caused harm. So, as people in the field of science or even science policy or in oversight of science, I think it behooves us to think about why we're doing whatever science we're doing, what we're doing, what is the purpose of it, who benefits from it, who doesn't benefit from it. Can we do things in ways that are more ethical or that benefit more people? Who has a say in the kinds of things that we do? We're having a lot of soul searching now in astronomy about our observatories. Now, I can't think of a more peaceful science than astronomy, right? We just have telescopes, we're collecting light from deep space, but we're finding out that at least over the past century, we've been plunking our telescopes on mountaintops wherever we please. And it turns out that some of these sites are very sacred to indigenous communities who didn't have any say about these telescopes being put on their sacred mountains, and realizing that even though the science we think is absolutely beautiful, the way we do it may not be so beautiful, and we should have, as a discipline, been more inclusive in making sure that all the affected voices are heard when decisions are made about what facilities are built and where they're built and who gets to use them and all of that. That's just one example. Within school communities and university communities, I think there's a daily opportunity to either be self-centered on the way one chooses to do one's research or get one's grants or do one's, work, or to be mindful of service, that one does one's work to serve others, either in student groups or making sure you're welcoming people in who might not have otherwise had a chance to come into the field, or sharing what we learn with the broader public, both those who traditionally have been able to learn what we are learning, and those in communities or places where it's harder for them to have the chance to learn, to appreciate, to have spirits lifted. Those are kinds of choices we can all make in whatever discipline we're in, and those are the kinds of things I think that I try to think about regularly as well.
I know from our time together this evening, I will long remember the call to pay attention and curiosity and beauty and the magnificence of the creation around us and the beauty around us. Been talking to Dr. Jennifer Wiseman, astrophysicist with NASA, also a fellow of the American Scientific Affiliation, director emeritus of the Program of Dialogue on Science, Ethics, and Religion for the American Association for the Advancement of Science. Please show your thanks, Dr. Jennifer Wiseman.
Thank you.
You've been listening to No Small Endeavor and our interview with astrophysicist Jennifer Wiseman. We gratefully acknowledge the support of Lilly Endowment Incorporated, a private philanthropic foundation supporting the causes of community development, education, and religion, and the support of the John Templeton Foundation, whose vision is to become a global catalyst for discoveries that contribute to human flourishing. Our thanks to all the stellar team that makes this show possible: Christy Bragg, Jacob Lewis, Sophie Byard, Tom Anderson, Kate Hayes, Mary Evelyn Brown, Carriot Harmon, Jason Sheasley, Ellis Osborne, and Tim Lauer. Special thanks to Harold Rubens and Danny Northup for production of the live event, and to Kendall Williams, Susanna Best, and Drew Gilmore for their hospitality in welcoming us to the Sudekum Planetarium at the Adventure Science Center in Nashville. Thanks for listening, and let's keep exploring what it means to live a good life together. No Small Endeavor is a production of PRX, Tokens Media, LLC, and
Great Feeling Studio.